Hello, welcome to day 12 of the Jamb Mathematics in 30 days. It's been a wonderful series so far, and to each and every one of you that has been following the series religiously, we say a big thank you to you. Keep your questions coming in. Anything you would like us to solve concerning the topics that we have treated so far, please put them in the comment section and we will definitely respond to them all. And if you have any other recommendations or whatsoever you would like to discuss to us about that, you can also put that in the comment section or reach out to us directly and we will also respond to you as quickly as possible. Now, to those who are seeing this video for the very first time, Jamb Mathematics in 30 Days is a series that we are doing here at Oya Learn to help students prepare better for their Jamb Mathematics exams. Now, in this series, all you have to do is just dedicate within 30 to 45 minutes of your time daily to just follow the series, watch the videos and practice. And by doing so, you will be getting every knowledge you need, all the necessary tools you need to get yourself fully prepared for Jamb Mathematics and to score a very good grade. I hope that you will join the series. If you are seeing this for the first time, please do well to check the series from day 1 up until this very point. And as always, please like, share and subscribe to the channel. As you do that, it helps us to be able to create more helpful content like this. Day 12 is all about mensuration, and if you want more about mensuration, you can always check out our videos where we discuss individual topics under mensuration in full details. Now, mensuration comprises of a host of other topics, right? And we have treated those topics individually. You find them on our playlist. But as far as Jamb exams is concerned, these are the objectives of the parts that you need to be very good at, you have to be conversant with, are listed here. So what Jamb expects you, the student, to know are the following. 1, they expect that you should be able to calculate the perimeters, areas of triangles, quadrilaterals, circles, and composite figures. That is, if you are given a certain circle, triangle, or quadrilateral as well as a circle, you should be able to find their perimeters and also be able to find their areas. Now, secondly, you are expected to be able to find the length of an arc or the length of a chord or the perimeter area of a sector and segment. So, for when you are dealing with arcs, chord, segments, sectors and the like, you should be able to find their length, you should be able to find their area as well for the sector and segment part. They also expect that you should be able to calculate the total surface areas of some solid shapes such as the cuboids, the cylinders, cones, pyramids, prisms, spheres, and other composite figures. And finally, they expect that you should be able to determine the distance between 2 points on Earth's surface using your knowledge of the great and small circles, that is longitudes and latitude. So now that we've looked at what Jamb expects of you, let's just go on to solve some questions on these objectives that we have itemized. Let us start with this question from 2010 that says a cylindrical pipe 50 meters long with radius 7 meters has one end open. What this means is that the other end is completely closed. Now, what is the total surface area of the pipe? Now, some just go straight and use the formula for this. There's an equation you can use to solve this. But if you're the type that does not memorize equations easily, let me show you how you can get the equation. So let's consider this as a cylinder. Pardon my drawing. Right? So at this point, assume that both ends are open. Now remember, in this question, one end has to be open while the other is closed. So at the part where it's closed, what you're going to have there is actually a circle of the same radius that covers this whole thing. So this will be a circle and then the open cylinder at both ends. Now if I should cut this cylinder, I can flatten it to have a shape like this, right? Where this is supposed to be the circumference of this circle. And the circumference of a circle is given by 2 pi r. While this distance here is h, so we put this as h. And when you multiply it, the area here will then be 2 pi r h. And for a circle, the area of a circle is given by pi r squared. Therefore, the total surface area of cylinder open at one end. This same statement could say closed at one end, would be given as the addition of these two areas here. So 2 pi rh plus pi r squared. Now, you can also find this same equation written as, when you look at these two, they have pi and r in common. So pi r open bracket left with 2h plus r. So these two equations are the same thing. It's just factorized at this point. So but I'll just continue to use this now. So we have r, we have h in this question, but pi is not given to us. Now, we usually take pi as 22/7. That's the closest number you can get to pi. However, if you look at the options provided here, the answers are provided in terms of pi. So which means we don't have to resolve pi. We just include it in our calculations. So let's go on to solve this. This will then be 2 pi multiplied by r, which is 7, multiplied by h, which is 50, plus pi multiplied by 7 squared. Now, 2 times 50 is 100. 100 times 7, that is 700. So we'll have 700 times pi to give us 700 pi, plus 7 squared would give us 49. So we'll have 49 pi. And when we add this together, we'll have 749 pi. So, and it's measured in meter squared. So the correct answer in this case is in option A. In this question that was set in Jamb 1990 and repeated in 2021, we see that we are told find the length of a side of a rhombus whose diagonals are 6 centimeters and 8 centimeters. Now, what do we know about a rhombus? Let's take this as a rhombus. One thing we know for sure is that all the sides are equal. So if this were x, this would also be x, and so on like that. Now, we are given the diagonals. This diagonal will be the longer one, while this being the shorter one. So if I should, let me draw the diagonals with broken line. And then do the same thing here. Another thing we know about the diagonal of rhombus is that just like some other quadrilaterals, the diagonals always bisect each other. So meaning that if this longer one were 8 centimeters, it means this is now going to be 4, just as this will be 4, and this will be 3, just as this is 3. Another thing we know is that they always bisect each other to form 90 degrees, right angles. So let's consider this part now. For example, this would be a 90-degree angle. Now let's call that out. You will then begin to see something that looks like so, with this being the right angle. Okay, and then we have the longer side being 4 centimeters, and then the shorter side being 3 centimeters like this. So meaning we are looking for side x that acts as the hypotenuse of this right angle triangle, which is also the length of the side of this rhombus. So now let's solve. Applying Pythagoras, when we apply Pythagoras theorem, it says that the square of hypotenuse equals square of opposite plus square of adjacent. So we would have x squared equals 3 squared plus 4 squared. So x squared equals 9 plus 16. Therefore, x squared is 25. So when we take square root of both sides, we find that x equals square root of 25, which is 5. And we are solving in centimeters. So 5 centimeters, giving our answer as B. In this question from Jamb 1979, we see that in this parallelogram PQRS, PE is perpendicular to QR. That is why you see we are having this here. which shows that this is a 90-degree at that point, a right angle. So in order to solve this, we know that when you have a parallelogram like so, the area is actually this length here multiplied by the vertical height, which I've represented with the letter x at this point. So we're having something like this, where this length now is this 5 and 7, but this x we do not know what it is. So let's go on to find the value of x. Here's the solution. To find x, we'll apply Pythagoras. Applying Pythagoras theorem. Now, Pythagoras says square of hypotenuse, because what we have there looks like this now, where this is the hypotenuse 12 and this is 5, but we are looking for x. So square of hypotenuse, that's 12 squared, equals, and then 5 squared plus x squared. So x definitely would then be square root of 12 squared minus 5 squared. So x is square root of, now this is 144. 144 minus 25, because 5 squared is 25, that's 119. And okay, square root of 100 is 10. Square root of 121 is 11. So this lies in between them, but it's closer to 121. So we'll just say this is approximately 11. So let's take it as 11 centimeters. Okay, working with this now, we can then go on to find the area. The area will then be this length here and multiplied by x. So x is 11 centimeters multiplied by the sum of these two now. We have 5 centimeters plus 7 centimeters. Now what this means is we have 11 times 12, and this is in centimeters squared. Now what is 11 multiplied by 12? That is 132, I believe. Let's check. 12 times 11. This is 2. This is 1. This is 2. This is 1. So yes, 132 centimeter squared. And checking with our options provided here, the correct is option D. In this question, we're told a rectangular pyramid has an area of 24 centimeters square and height of 7.5 centimeters. Find its volume. Now, in order to solve this, here's something we need to know. The volume of a rectangular pyramid is length times breadth times height over 3. But we have already been given length times breadth, which is area. Area is length times breadth, so I can just say area times height all over 3. So this is what we have to apply. But I'm saying we have a 7.5 here, so to solve it easier, let me convert that into a fraction. So 7.5 is something as saying 7.5, which is basically 2 times 7, that's 14 plus 1, so we have 15 over 2. So now all we have to do is just apply that. So the area here is 24. So 24 times the height, which we have just converted here, that's 15 over 2, all divided by 3, right? So we can then break this gradually. We can go from here, say 2 here 1, 2 here is 12. So now we have 12 times 15 divided by 3. And then we can then break this and say 3 here 1, 3 here 4. So what we have is 4 times 15. And 4 multiplied by 15 is going to give us 60. So that's 60 centimeter cubed. So the volume is 60 centimeter cubed as seen here in option D. This question from 2023 states that the perimeter of an isosceles right-angled triangle is 2 meters. Find the length of its longer side. Now, to solve this, let's first have ourselves a diagram to represent what we have. Now, where this is equal to this, so the longer side, let's call that x, and the other two sides that are equal, since it's an isosceles, let's make that this and this. So let's call them y. and y, since they are the same. Now at this point, when we apply Pythagoras, hypotenuse squared should be equals to opposite square plus adjacent squared. So we can then say x squared equals 2y squared. Then x itself will be square root of 2y squared. So call this equation 1. Now the question itself tells us that the perimeter is 2 meters. If the perimeter is 2 meters, therefore it means that x plus y equals 2. So that is x plus 2y equals 2. And then x is 2 minus 2y. So call this equation 2. Now we have two equations that are both telling us about the same thing, which is x. So what we usually do here is we equate those equations. So equate 1 and 2. Now what this means is that since this is x, we will then say that this equals this part that is also x. So let's pick this first. So we have 2 minus 2y equals the same x here, which is square root of 2y squared. Now I want to get rid of this square root, so I will square both sides. So that means we'll have 2 minus 2y multiplied by itself, 2 minus 2y equals, then the square root here will be gone, so we'll have 2y squared. Now expanding this, 2 times 2, 4. 2 times minus 2y, that's minus 4y. Minus 2y times 2, minus 4y. Minus 2y times minus 2y, that will give us plus 4y squared equals 2y squared. Collect like terms. 4y squared, this coming here, minus 2y squared. And then we have minus 4y plus 4, so all equals 0. 4y squared minus 2y squared will give us 2y squared. Minus 4y, that's minus 8y. Then plus 4 equals 0. At this point, we can divide through by 2 to simplify the equation even further. That way, we can say y squared minus this divided by 2 would give us 4y. And this divided by 2 will give us 2. So it's still the same equation. I only divided through by 2. Now, we'll solve this quadratic equation using the formula method. In this case, we know that a is 1, that's the coefficient of y squared. B is minus 4 and C is plus 2, right? So applying the quadratic formula, we will then say y equals, now the formula states, let me write the formula here. When you are looking for an unknown, let's say x is the unknown, for example, you're going to have negative b plus or minus square root of b squared minus 4ac all over 2a. So this is what we are trying to apply here. So we are supposed to have minus b, and b is minus 4. So minus times minus 4, that is plus 4. Plus or minus square root of b squared. So minus 4 in bracket all squared, that will give you plus 16. Minus 4ac. So 4 times a, which is 1, that's 4, times c, which is 2, and then we have 8. All over 2 times a. 2 times a is 1, so that is 2 straight away. From here, we can then say that y equals, so I break this down to say 4 over 2 plus or minus square root of 8 over 2 as well. So from here, I can see that my y is 2 plus or minus 2 root 2 over 2. So 2 here cancel 2. And then y equals 2 plus root 2 or 2 minus root 2. Now, let's come back here. The perimeter of this entire shape is 2 meters. So there is no way the length of one side is going to be greater than 2. Therefore, we're going to work with this as the value of y. So this will be the accepted value of y. Now, if this is the accepted value of y, let's come back to this equation where we have the value of x. We then say x equals 2 minus 2 into y. Now, what's the value of y? y is 2 minus root 2. Now, let's tidy this up. X therefore becomes 2 minus 2 times 2, that's 4. 2 times minus sod 2 here, that's minus square root of 2. That will give us plus 2 root 2. Now, x therefore becomes 2 minus 4. That is minus 2. And then this would give us plus 2 root 2. And this is the value of x. So let's check our options. Okay, here we go. We have 2 minus root 2 here. We have b 4 minus 4, 3 root 2. And then we have here minus 2 plus 2 root 2. Yes, so that is the correct answer. Option D. A circle has a radius 13 centimeters with a chord 12 centimeters away from the center. Calculate the length of the chord. For videos like these and more helpful videos, please subscribe to our channel and click the notification bell, which will alert you every time we put in a new content like this for you. Now, to solve this problem, what we'll do is to visualize it at first. So let's take this as a circle with center here. And then let's draw a chord that will be 12 centimeters away from this center. That is, if we take a distance of 12 centimeters like this, then we can then place our chord like this. Now, there is a theorem that states that when you draw a line from the center of a circle to meet a chord, that set line is going to meet the chord and create a right angle in this case, and it will also bisect the same chord. So now we also know that this same circle has a radius of 13 centimeters. So let's just pick one side and draw a radius that will come from the center to the tip of this chord, like so. So this is 13 centimeters. So we have a right angle triangle here, and we know this length here is same as this length here. So let's just call this x and this as well x. So the length of the chord is going to be 2x. Of chord is 2x, right? So, but let's find the value of x by applying Pythagoras. When we apply Pythagoras theorem, it says that the square of the hypotenuse, that's 13 squared, should be equal to square of opposite 12 squared plus square of adjacent x squared. So from here I can go straight and say x equals square root of 13 squared, which is 169, minus 12 squared, which is 144. So what we are looking at here is the square root of 25. So x is therefore 5 centimeters. Now remember, length of chord is 2x. So length of chord equals 2 times x, which is 5 centimeters, and this gives us 10 centimeters. So the correct answer is D. In this question, we're asked to find the area of the figure above. So to solve this problem, we're to find the area of this figure. We see we have a rectangle here, and this rectangle, the area will be length times breadth. And this is a semicircle. The area of a circle is pi r squared. So half of that will be pi r squared over 2. But here we have the diameter, and radius is diameter over 2. So that is, our radius is 5 over 2. If we are looking for that now. So let's go on to do this. So we're supposed to add this area and this area together. So the total area is going to be 15 centimeter times 5 centimeter, that is for length times breadth, plus, now for the semicircle, pi is 22 over 7. So we say times 1 over 2 for the over 2 here, then times r. R is 5 over 2, all of these squared. So let's tidy this up. Area therefore becomes, what is 15 times 5? This is 25 here. Carry the 2. 5 times 1 is 5 plus 1. That's 7. So we have 75 centimeters squared plus. Now let's break this. We have 22 over 7 times 1 over 2 times. This is 25 over 4. Because when you square this, that's 25. And when you square this, you get 4. Right? So working with this, we see that 2 can go here 11 times. And then we would have A equals 75 centimeters squared plus. Now you can compute this with your calculator. All you need to press is 11 times 1 times 25, all divided by 7 times 4. And that would give you 9.82 centimeter squared. Now when we add these two together, we're going to have, this is 2, this is 8 point. Now 5 plus 9, that's going to give us 14. So 4, carry 1 plus 7, that is 8. So we have 84.82. Now when we look at all our answers there, we see they are to one decimal place. So area will be approximately 84.8 centimeter squared, which is D. In this question, we have that we have to find the angle subtended at the center of a circle by a chord, which is equal in length to the radius of a circle. It looks quite a little bit tricky, but once you get to understand it and visualize what is in the question, you should be able to solve it without a problem. Now, when you look at this, let's take this as a circle, right? And then we are going to now make an angle that subtends at the center of the circle by that chord. So if this is the chord we are talking about, let this be the chord we're talking about, and this be the center of the circle O. All we need to do is just draw lines to meet our chord. Now, recall they said the chord is equal in length with radius. So this point here to this point is radius, which is equal to this. And since this is also equal to it, what we have here, you see, is an equilateral triangle. So what we need is particularly this angle. However, in an equilateral triangle, all angles are equal. So since sum of angle in a triangle is 180, if this angle is theta, theta would therefore be 180 degrees divided by the number of angles we can find in this equilateral triangle, which is 3. So the answer is 60 degrees. So we are going to pick option C. Let's take a look at these questions that ask us to find the length xz in the triangle above. And when we look at this triangle, xyz, we can see that it has one side length being 1 meter, the other being 2 meters, and we know for a fact that this third is going to be longer than 2 as well as it is longer than 1. So we can see that the three sides of this triangle do not have equal length. So we are looking at a scaling triangle. And when you are trying to solve a scaling triangle, the go-to rule is to apply either sine rule or cosine rule. And it's advised, depending on what you are given. If you have 2 side lengths and 1 angle, we apply cosine rule. And when you have 2 angles and 1 side length, then we apply the sine rule. So in this case, we have 2 side lengths, looking for the third side length, but we have one of the angle. So in this case, we're going to apply cosine rule. Now, applying cosine rule, what we do is this. The side opposite angle x is denoted small letter x, which is 1 meter. Opposite z, we have small letter z here, which is 2 meters. And opposite y here, we have small letter y, which is what we are looking for, the side x, y. And using this, cosine rule states that y squared will equal x squared plus z squared minus 2xz cos y, where this is the angle and these are side lengths. So let's apply it. Y squared therefore becomes x. Now x is 1, so 1 squared plus 2 squared minus 2 times 1 times 2 multiplied by cos y. Y is 120 degrees. Now applying this, y squared then becomes 1 squared is 1 plus 2 squared, which is 4. We see that we have 5 here. 1 plus 4, that's 5, minus 2 times 1, that's 2, times 2, and we have 4, multiplied by cos 120 degrees will give us negative half. Now from here, y squared equals 5 minus times minus, that's plus. 4 times half would give us 2. So y squared equals 7, which implies that y is the square root of 7. So the correct answer here is A. 7 meters. This question says the angle of a sector of a circle of radius 10.5 centimeter is 48 degrees. Now calculate the perimeter of the sector. Now to put this in perspective, consider this the circle where we have the center here. So if the angle of the sector is 48 degrees, this would be a sector. So let's call this angle 48 degrees. So we see that this is just part of a circle, right? And if a circle makes 360 degrees, therefore this would be the ratio of this angle to 360 multiplied by the perimeter of a circle, or what we call the circumference of a circle. So here's how we solve. This would be 48 over 360 multiplied by the circumference of the circle, which is 2 pi r. Now let's work with this. Pi, we're going to take that as 22 over 7, and the radius is given as 10.5, which is something as 10 and a half, which when converted into improper fraction, we're going to have 21 over 2 in centimeters. So now let's compute this. So we'll have 48 over 360 times 2 times 22 over 7 times r, which is 21 over 2. Now let's break this down gradually. 2 here, 1, 2 here, 1. 3 goes here, or 7 goes here 3 times. 7 goes here once. 3 goes here once. 3 goes here 120 times. And when we break this a little further, we see that 12 goes here 4 times, and 12 goes here 10 times. So what we have left is 4 times 22 over 10. Now 4 multiplied by 22 would give us what? Now this will give us 8. So we have 88 divided by 10. So from here, 88 divided by 10 will give us 8.8, and it is measured in centimeters, so centimeters. So the correct answer is option A. In one of the questions we've solved earlier, we established the equation used to find the area of a trapezium as this. So we said area is 1 over 2 multiplied by the sum of the parallel sides multiplied by the distance between the parallel sides. So take note, A and B are the lengths of the parallel sides of the trapezium. while h represents the distance separating them. So let's apply that to this. The area of this trapezium is given as 91 centimeters squared. So 91 equals 1/2 into, now the sum of the parallel sides, we have 5 plus 9, all multiplied by h. So if we take 2 here, we would have 2 multiplied by 91 equals, now 5 plus 9 would give us 14h. From here we can then say h equals 2 times 91 over 14. So we see here that 7 goes here, as in 2 goes here 7 times, while 2 here is 1. So we are left with 91 over 7. And 7 times 13 gives us 91. So that means 7 will go in 91 13 times. So we'll have 13 centimeters. So the correct answer is in option A. Now you can do well to check out more videos on mensuration here on our channel, where we explain it in more details, and then practice with many other questions you can find around you. And as usual, don't forget to like, share, and subscribe. Tell a friend about the Jamb Mathematics in 30 days and the beauty of this Oya Learn channel. See you in the next video.